Here's a number. It's not a binary number, it's a decimal number. It's probably called decimal because there are 10 symbols. Here are the 10 symbols. And we developed it because we've got 10 of these. And it's useful to count. So here's a number, 5,823. And when we're teaching children to count, we usually say 5,000s, because there are 5 of them, 800s, 2 tens, and 3 units. Now there isn't really a nice name for this. I hate the word unit, but ones, I suppose you could say. But we usually say 3 units. And we use those special blocks to teach children in. Anyway, here's a different number. It's 5,000, 5,000s, no hundreds, 2 tens and 3 units. And it's important that children remember that this, although this 0 means nothing, here it's a very important nothing, and it's important that we keep the numbers separate and that we keep these columns separate. So if we look at the columns, here's the ones or the units. There are 3 of them, there are 2 tens, there are no hundreds, and there are 5,000s. Although this is nothing, as I said, it's very important. We probably don't need this 0 to mean no 10,000s, and we don't need the next one to mean there are no 100,000s or no millions. It's just not important. This 0 we can get rid of, but this 0 we definitely can't, because this now becomes a totally different number. And we all know as adults that this number is totally different to this one, but it's still important to reiterate this when we teach maths to young children. So let's look at this number. Now this is a binary number, and it's binary because there are 2 symbols, zeros and ones. Here are the binary numbers, but in columns. So here's the columns, the 1s, the 2s, the 4s, the 8s, and the 16s. And that's a bit weird because they just times by 2 each time. And so there's 1, 8, there's 1 in the 8 column, and there's 1 in the 4s column. So already it's 8 plus 4. This is my decimal working out row here. 8 plus 4. There are no 2s, so there's not going to be any, and then there's 1, 1. Perfect. So all added together, 8 plus 4 plus 0 plus 1 is 13 in decimal. And my decimals are going to be magenta, this pink colour from now on. So 1101 in binary is equal to 13 in decimal. Now interestingly, there are 2 digits here. All of these digits aren't actually called digits, they're called binary digits, or bit for short. So there's 4 bits here. There's 1, 2, 3, 4 bits, and together they make the decimal number 13, which we can represent with 2 digits. That's a bit rubbish. We've got to use 4 bits to express 2 digits. It's a bit inefficient, but it's very useful in computing. So let's use a bigger number. We can see the columns, we've just extended them. So we've got 16s, 32s, 64s, 128s, 256. It goes on forever, obviously. This is a very important number in computing, using 7 of these bits in one go. Okay, so this is all of the answers. There's 164. There's 132, there's there's no 16s, there's 8, there's no 4s, there's no 2s, and there's 1s. And altogether this makes 64 plus 32 plus 0 plus 8 plus 0 plus 0 plus 1. And I recommend you write them out in this way, because then the maths becomes trivial. Okay, you've got to make sure your adding up is right, and it's 105 altogether. So here's a question, write the number 20 in binary. That's what usually happens. So instead of going from this way and saying, oh, can you write the number 1101001 in decimal? That's quite easy, because you can just work out the columns, plug it into the columns, write out this row, and then you're done. For however big this is slightly more tricky. So we've got to get from decimal into binary, not from binary into decimal. So we've got the number 20. Let's write out our columns. It doesn't help us yet because we don't have the binary thing. We can't work this out. So we've got 1s, 2s, 4s, 8s, 16s. And what we go is we work upwards from 1s, and we go 1s. How is 20 bigger than 1? Yes, it is. Is 20 bigger than 2? Yes, it is. Is 20 bigger than 4? Yes. Is 20 bigger than 8? Yes. Is 20 bigger than 16? Yes. Is 20 bigger than 32? No. So there must be 0 64s and 0 32s in 20. But there is a 16. So I've put down a 1, and I know already that that's 16, so here's my working out row. There's 1 16 in 20, but that isn't the whole story. It's not just 1 0 0 0 0, because that's 16. So is there 1 1? Well, this together makes 16 and 8, because there's 1 16 and 1 8. Oh, damn, that's 24. Well, that's too big. So there can't be 1 1. It must be 1 0 in these columns. So here we have 1 0, 16 plus 0. Of course, this isn't finished yet because it's still just 16. So now we're going to go, okay, is there a 4 as well? So now it's 1, 0, 1, and then something over here. 16 plus 0 plus 4 is 20. Fine, so is the job over? Well, no, because there are still these columns here. Because 101 is very different to this number. Oh, what have I done here? 16 plus 4 plus 2. Maybe there's 1, oh no, this makes 16 plus 4 plus 2 is 22. So these two final columns have to be 0. 16 plus 4 plus 0 is 20. So the answer to write the number 20 in binary is 10100. We don't need these zeros, but we sure as hell need these ones.